All right, let's get into some review practice using trigonometric ratios and specifically our special angles. Before we get into anything, let's review some sort of key vocabulary here. There's 4 terms that you really need to know. Truly, you really only need to know the top 2. The bottom 2 are going to help us describe things. I'm just going to draw a random angle here off of my Cartesian grid. The first term that we are looking at is our principal angle. And the principal angle is the angle between the positive x-axis, so this guy, and the terminal arm. And that arm that I just drew, that is your terminal arm. That's the one where it's ending. So to figure out my principal angle is going to be this guy. Principal angle. We start at the positive x-axis and we rotate around to the terminal arm. Okay. Next up, I have my related acute angle. This is the angle between the x-axis. Note that it doesn't matter which x-axis, between any x-axis and the terminal arm. In this case, with my terminal arm, which x-axis is closer? Well, it's the negative x-axis. And so my related acute angle is going to be this one. And we also just call this an RAA. I'm just going to use that shorthand here to make things easier. Okay, I'm going to add a label here, remembering that this is the terminal arm. Next up, we have the positive angle, and I'll do that in green. The positive angle is the angle rotating counterclockwise from the positive x-axis. So our positive angle would be like this to figure out the angle of the terminal arm. That's the positive one. The negative angle is going the other way. You're going counterclockwise from the positive x-axis. We would start here and go backwards. So if you've got a positive angle, you're going counterclockwise. You're going to the left. If you've got a negative angle, you are going clockwise. Okay? Negative and positive. Cool, we've got some vocab down. Okay, now we have to remember our primary and reciprocal trig ratios. This is your favorite SOHCAHTOA. Yay, fun fact, my dog's middle name is SOHCAHTOA. We got him when I was in high school, and I thought that was hilarious. Okay, let's write them all out. Our primary ratios, there are 3. We have our sine ratio, is opposite over hypotenuse. Our cosine ratio is adjacent over hypotenuse. And our tan ratio is our opposite side over our adjacent side. Those are our primary trig ratios. Then we have our reciprocal trig ratios, and you may be familiar with these, you may not be familiar with these. That's okay. They're really straightforward. The first one is cosecant. Cosecant. Which is 1 over sine, or it's just like the reciprocal version, of sine. So we just flip it. It's hypotenuse over opposite. It's called cosecant. The reciprocal ratio associated with cosine is called secant. Don't ask me why cosecant doesn't match with cosine. It just doesn't, because math. Secant is 1 over cosine, or you just flip it, hypotenuse over adjacent. And last but not least, we have we have cotangent, cotangent, that's 1 over tan or you just flip and you do adjacent over opposite. Good. We remember sine, cos, tan, we remember SOHCAHTOA, and you remember, or now know, cosecant, secant, and cotangent. Another piece of information that you should be remembering from grade 11 would be your cast rule. What was the cast rule? The cast rule was a very helpful rule to help us remember in which quadrant, or sorry, which ratio is positive in each quadrant. And you start in quadrant 4 with a C, A, S, T. You may have learned it differently, in a different order. All that matters to me is that you remember in which quadrants which one is positive. In quadrant 1, all of the primary trig ratios are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. C-A-S-T. That was our cast rule. Okay, and some people know it as the ASTC. Doesn't matter. Okay, let's do some questions. Whew, already I know. For each trig ratio, draw a sketch of the principal angle and state the sign of the ratio. So what we are being asked to do is we need to actually sketch this baby. So I'm going to do that. I'm literally going to take a ruler. And I've put a hint at the top here. In order to help you sketch, you want to split the top half of the grid into the number of slices of the denominator. So what is our denominator? Here it's 4. So I need to split my top half into 4. It's already been split in half for me. And so I'm going to go ahead and I'm going to split it into quarters. And just to be smart, I'm going to do the whole circle. Ish. Doesn't have to be perfect. We just get the idea. Okay. We are going to now draw the principal angle. Each of these is a quarter pi, and I have 7 of them. So we'll sketch. I have 1, 2, 3, 4, 5, 6, 7, all the way around. We draw an arrow at the end. Okay? Again, I just counted how many quarters. 1, 2, 3, 4, 5, 6, 7. We've landed in quadrant number 4. Let's apply our cast rule now. According to the cast rule, in quadrant 4, only cosine is positive. Our question here says sine, therefore our ratio is going to be negative because it is in quadrant 4. Okay, let's do another one. Cotangent of negative 7 pi by 6. Okay, first things first. Let's split this up into sixths. We already have some kind of a helpful line. This is going to be hard to do, but we're going to do it. We need to split up this into a thirds and then this into thirds. So we're going to do our best. That's actually not that bad. Keep going. That one should probably be a little bit higher. Okay, there we go. Got a few going off the grid here. Okay, this is now sixth across the top, right? 1, 2, 3, 4, 5, 6. It is indeed. Now I'm going to draw my angle. Note here that our angle has a negative sign, so I'm going to go backwards. I'm going to go clockwise, starting from my positive x-axis. So I need 7/6. 1, 2, 3, 4, 5, 6, 7. Try a little smoother. 1, 2, 3, 4, 5, 6, 7. There we go. I can add my, I'm just going to highlight both of these with their terminal arms so that we can clearly see where the terminal arm is. And then once again, I'm going to apply the cast rule. Here I'm dealing with cotangent, which is just tangent but upside down, so the same rule is going to apply. Tangent is only positive down here and up here. We land in quadrant number 2 where sine is positive, and so we're going to say that this is going to also be negative. So how does this method work, or why does it work in terms of doing the splitting up bit? Recall that 180 degrees, or a straight line, is pi. And so what I've actually done is I've split this. When I split a line into like 4 or into 6, I'm splitting it actually into pi by 4 or pi by 6. We can just sort of ignore the pi because it's sort of built into the fact that it's a straight line. Cool. Okay, another example that we're going to do here, we need to state an equivalent expression in terms of the related acute angle. Okay, let's sketch. We're going to start with our first one here. Cosine of pi by 6. I need once again to split my Cartesian grid into sixths. And I'm doing my best to do that. Cool. Get rid of these little extra tails here. Got a little too excited. Okay, awesome. It's positive, so I'm going to go the positive way around, and I need to go around 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Awesome, and here's my terminal arm. Okay, so what would be an equivalent expression? We've got a couple of different options here. The one that I sort of see is, well, we could go backwards, right? If we went from the positive x-axis down, we would land at the same spot. So one equivalent expression would be cosine of negative pi over 6. Another option might be cosine of positive pi over 6. And we get that because we know that cosine is positive down here. So whatever this answer is going to be, it's going to be positive. It's also going to be positive up here in our A rule for our cast rule. So this arm is going to give the same result as that arm. And if you're like, what are you even saying right now? No problem, we'll get there. Okay, let's do a next one. We have cotangent of negative 3 pi by 4. I start by splitting things up into fourths. Awesome. And now I'm going to go backwards by 3. 1, 2, 3. And highlight my terminal arm. Okay, what's another option for what this could be? We've got a couple. This would be the same thing as if I were to go forwards by 1, 2, 3, 4, 5 instead. Or alternatively, where are we in terms of a related acute angle? Well, my related acute angle is down here, right, coming in from the x-axis. Just like we saw over this one, we have a related acute angle down here. According to my cast rule, C-A-S-T, tangent is positive here, which is awesome. And so where else is it positive? Well, it's positive in quadrant 1. So I could also do this. I could also say that this arm would give me the exact same result. I'm working with a smaller fraction, a little bit easier, and no negatives. And so that's what I want you to think about is, let's find that related acute angle, and in what quadrant am I going to get the exact same answer? Cool. Down to question C. I have cosecant of negative 4 pi by 3. So I need to divide my axis into thirds across the top, and I'm actually going to erase my y-axis here because I find it to be a little bit difficult when doing thirds. So we split this up into thirds to the best of our ability. And so cosecant of negative 4 pi over 3 would look like this. I'd go 1, 2, 3, 4, and I would land here. According to my CAST rule, my CAST, where am I going to get the same answer? Well, first off, I have a related acute angle here already going this way. Okay, my related acute angle is pi over 3, and so where else is pi over 3 happening where it ends up being positive? Well, it's in my quadrant number 1. And so another alternative of doing this is if we were to go this way. And so it would be CSC of pi over 3. CSC of pi over 3 would also end up being positive. Okay, last but not least, I have sine of 4 pi by 3. Once again, I've got a pesky denominator of 3, so I'm going to erase my y-axis and split this up into thirds. Ish. Okay, it's positive, so I'm going to be going around the normal way. 1, 2, 3, 4. My terminal arm. My related acute angle is pi over 3. I'm going to add my CAST rule in. Interesting. So here we have the answer for this guy is going to be negative. So where else is it going to be negative? Well, it's going to be negative in quadrant number 4. So we could also go right here. And this would give you the same answer because it's also going to be negative. So a similar would be sine of negative pi over 3. Cool. Okay, let's take a look now at our special triangles. These are special triangles that you will need to memorize. You will. No options. Hopefully you've seen them in grade 11. You may have just seen them in degrees and instead of radians. So I'm going to introduce the radians one into, and you just need to memorize it. We have two special triangles. There was the 45 triangle in degrees. What that looks like now, so our side lengths remain the same of 1, 1, and root 2. We have a pi by 4 and a pi by 4. Pi by 4 is the equivalent of 45 degrees. Okay, this one is pretty straightforward to remember. You just really have to remember that it is pi by 4. The trickier one I find is the other one, the 30, 60, 90 triangle. So the way that I try to remember on how to draw this and reconstruct it, because you will be expected to do that on your own, the smallest side is always 1. Then we go 2 for our hypotenuse, 3 with a square root. So if you can remember that square root of 3 is between 2 and 1, then you could do it in order of lengths. And then we need to build in our angles here. So the way that I remember it is I remember that this angle, pi over 3, the denominator is the same. Well, that's hard to read. The denominator is the same as what's underneath the square root. So the 3's are sort of across from one another. And then the other interior angle is pi over 6. So these are two special triangles that you need to memorize. And the reason that we use these special triangles is in order to help us to determine the exact value of a trigonometric ratio. Okay, so when we determine our exact value, the very first thing what we want to do is we want to draw a diagram of the principal angle, and then we want to draw a triangle with our related acute angle, including our terminal arm. Okay, so let's do that for the first one. We're going to work through all the steps. Here I have tan pi over 3. Oh gosh. Get rid of that and get rid of this. Okay, let's draw it in. I need to split this into thirds. And I'm going to go 5 pi over 3. 1, 2, 3, 4, 5. Okay, my related acute angle is the one that's closest to the x-axis. It's in here. Now what I'm going to do is I'm going to draw a right triangle using my terminal arm and the related acute angle. So my triangle is going to look like this. And I'm intentionally highlighting because I don't want to overlap anything here. Okay, here we have a pi by 3 situation, right? We have 5 pi by 3's. Inside here is also a pi by 3. And so that's going to indicate immediately which triangle we are dealing with here. Remember the 3's are across from one another, so this side is square root 3, which means that my hypotenuse is over here at 2 because I got a right angle, and then up here is 1. My last interior angle is pi over 6. And then the last thing I have to remember is that this side length is in the negative y-axis. It's going down, right? Our y-axis is over here. This is actually negative. So my pi over my square root of 3 is actually going to be a negative square root of 3. And so given my related acute angle of pi over 3, I have been asked to find tan of that. Well, what is tan of 5 pi over 3? We have negative, its opposite is negative root 3, divided by my adjacent, which is 1. So the exact answer for tan of 5 pi over 3 is actually negative root 3. Okay, we're cool. Let's do another one. We've got a whole bunch here to practice with. Okay, I've been asked to find secant of 5 pi over 6. As a refresher, secant is hypotenuse divided by adjacent. It's the flipped of the cosine. Let's start by sketching this. So I have pi by 6. I need to split my grid into sixths. Something like that. Okay, and then let's sketch 5 pi by 6. I'm going to go 1, 2, 3, 4, 5 all the way here. So my terminal arm is this guy. Cool. My related acute angle is going to be in here. And I'm going to finish off that right angle right here. If we know that this whole thing is pi, and I've already gone 5 pi by 6, then that must mean inside here, there's a pi by 6. And I'm just going to make this triangle a little bit bigger. If this side is pi by 6, or if this angle is pi by 6, then that means the top one is pi over 3. And now we can go ahead and we can build in our triangle. The 3's are always across from one another. 1 will be across from pi over 6, and my hypotenuse is always 2. Now we check, should any of these side lengths be negative? Hypotenuse is never negative. 1. That's going up my vertical x-axis. It's positive, so no, I don't need to. This side of my triangle is going along the negative x-axis, and therefore this should be a negative root 3. Now the question was asking for me to find secant. Recall that secant, as I wrote above, is hypotenuse divided by adjacent. So the hypotenuse in this triangle is equal to 2. And the adjacent side to my pi by 6 is negative 3. So the exact answer here of secant 5 pi by 6 is 2 divided by negative 3. Hopefully you're starting to see the pattern here in how we're solving these. Let's go on to question C. Cosecant of negative 4 pi by 3. Cosecant is the inverse of sine. Sine is opposite over hypotenuse, so what I'm looking for is hypotenuse divided by opposite. All right, I need to sketch my angle here. I'm going to hide that pesky y-axis. Cool. And now let's split it up into thirds because that's my denominator. I think that might be my best thirds yet. Yeah, sort of. Okay, let's sketch. Negative 4 pi by 3, so I'm going to go backwards. 1, 2, 3, 4. So my related acute angle is inside here at pi over 3. And I'm going to draw in now my matching triangle. If this angle is pi over 3, the one at the top is going to be pi over 6. My side, my vertical side, will match up with my root 3 because the 3's match up. My hypotenuse is 2, and the other side is 1. Now I got to see, should any of these be negative? Hypotenuse is never negative. The square root of 3 is in the positive y-axis, so it remains positive. The 1, however, is in the negative x-axis, so I need to add a negative 1. Okay, the question is asking for me to find hypotenuse divided by opposite. The hypotenuse in this triangle is 2. Opposite my angle is root 3, so the precise answer is 2 divided by root 3. Okay, we're going to do 3 more, and then hopefully you'll be sort of comfortable. You'll get the gist of what we're doing here. Cosine of 5 pi over 4, and I lost my grids to the next page, but that is okay. I'm going to draw my Cartesian grid. I need the top split into fourths. Cool, cool. Okay, I'm going to draw my principal angle, negative 5 pi by 4. 1, 2, 3, 4, 5. Beauty. All the way up here. My related acute angle is inside here, and it is pi over 4. Again, this was pi. Each of these are pi by 4. So that guy's pi by 4. Let's split this into a lovely right angle triangle. We're dealing with our other special triangle here, our 45, 45, 90 triangle, where both angles are pi over 4, both sides are 1, and the hypotenuse is root 2. We ask ourselves, should any of those numbers be negative? Hypotenuse is never negative. Along the y-axis here, this one is positive. However, along this x-axis, it's negative, so I need to add a negative 1 there. The question is asking me for cosine. Cosine is adjacent over hypotenuse. Adjacent to my related acute angle is negative 1. And my hypotenuse is root 2. So the exact answer for cosine of negative 5 pi by 4 is negative 1 over root 2. All right, E, sine of pi over 2. You should just know this one. This is 1. How should you just know this one? Well, that is one of the key points of your sine function. If you think about it, and I'll sketch it real quick. In your sine function, I have a pi, 2 pi, pi over 2, 3 pi over 2. Your function looks like this, for the most part. Where the max is 1, the min is negative 1, so pi over 2, the value is just 1. So sneaky, so sneaky. Okay, one last one for real. Cotangent of negative 7 pi over 6. Let's add our Cartesian grid, and then I'll split it up into sixths. Awesome. Let's draw our principal angle. Negative 7 pi over 6. I'm going backwards. 1, 2, 3, 4, 5, 6, 7. My related acute angle is right in here, and it's pi over 6. So I'm going to draw the matching triangle I have to it. If this is pi over 6, let's make this whole thing bigger. There we go. If that's pi over 6, then this angle must be pi over 3. And so I can fill in the blanks here. I'm just going to make that smaller. The sideways or the horizontal side is going to be root 3 because the 3's are always across from one another. 2 is my hypotenuse and 1 is my other side, my last side standing. Should any of these be negative? Correct. Then root 3 should be negative because it is along the negative x-axis. 2, the hypotenuse, is always positive, and this 1 here is along the positive y-axis. Cotangent, you'll recall, is the inverse of tangent, so it's adjacent over opposite, and that is what I am looking for here. So my adjacent side to my related acute angle, pi by 6, is negative root 3. And my opposite side is 1, and I can just simplify that to negative root 3. Hopefully you sort of got the gist for how we were sketching all of these. We have a lot of different things here. going on. It's a lot of repeated algorithm, a lot of repeated steps, and at the end of the day, you are getting the exact value of the trig function, which is what we're going to be building on for the next couple of lessons.